So next, the important concept is graph traversals. So traversal is nothing but accessing each element exactly once. Graph traversal is the problem of visiting all the nodes in a graph in some particular manner. There are two methods of graph traversals. One is DFS and another one is BFS, depth first search and breadth first search. So first I will be discussing about DFS. So here the algorithm starts with one arbitrary vertex. So that vertex is being marked as visited. So for the next iteration, the algorithm proceeds to an unvisited vertex that is adjacent to the one that is currently in. So the process continues until a vertex with no adjacency, unvisited vertex, is found. So here the data structure used is stack with last in first out fashion. This is algorithm for DFS. Step 1, initialize all the vertex in the graph. Step 2, push the starting vertex onto the stack. Step 3, repeat step 4 and 5 until stack is empty. Step 4, pop the top vertex from the stack. Step 5, push on to stack all neighboring vertices of the popped vertex. Step 6 is exit. So consider this example. So this is underrated graph example for DFS. Same example I have written here, DFS. First, write all the nodes with the adjacency elements. So starting from A, node A, B, E with the adjacency elements, B, G, D, next B, the one that is alphabetically closer to A is B. So next the vertex node is B. Node with the adjacency elements. Next E. Next G and so on. First write the adjacency elements for the nodes. Next, this is stack representation and list visited. So first, the nodes adjacent to node A are B, G and D. The adjacent element to node A are B, G and D. So first we are starting with the node A. So first A is pushed onto the stack. And it is also added to the list as visited. Right. So the adjacents element for node A is B, G and D. The one that is alphabetically closer to A is B. So now vertex B is pushed onto the stack and it is also added to the list as visited. B, and it is also added to the list visited. So now the top of the stack is B. The adjacent elements of B are A, E, F. So A, which is already visited, the one that is alphabetically closer to B is E. So E is now pushed onto the stack and also added to the list as visited. Next, the node that is adjacent to E are B and G. So here B is already visited. So not visited vertex is G. So now G is pushed onto the stack and added to the list as visited. Next, G is on the top of the stack. The adjacent elements of G are A and E. A, E. So it is clearly observed that A and E nodes are already visited. So E is the adjacent nodes of G. So G is now top of the stack. So the adjacency elements for the node G is E and A. So E and A is already visited. So therefore G is popped from the stack. Now the top of the stack is E. E, which has the adjacency elements B and G. E, B, G. The adjacent nodes of E are visited. So now E is popped from the stack. Now top of the stack is B. The adjacent node of B is A, E and F. A, E, and F. So the adjacent node of B that is not visited is F. So A is already visited, E is already visited. The one which is not visited is F. So now F is pushed onto the stack and added to the list, visited list. So now stack contains A, B, F. Now the top of the stack is F. The adjacent node of F is B, C, D. So B is already visited. So now C is pushed onto the stack and added to the list visited. Now C is on the top of the stack. The adjacent unvisited node of C are F and H. The adjacent unvisited node of the unvisited node of C is H. So F is already visited. Next is H. So now H is pushed onto the stack and added to the list visited. So now H is on the top of the stack. So adjacent node of H is C. So C is already visited. So now we are going to pop H from the stack. Now the top of the stack is C. So H is popped from the stack, so that the top of the stack now becomes C. So the elements, the adjacency element of C is F and H. So here the all nodes are visited. So C is popped from the stack. Next to top of the stack is F. So F with the adjacency elements B, C, D. So B is already visited, C is already visited, then the last is D. So D with the adjacency A and F. A, F. So D, we want to, D is pushed onto the stack, then added to the list visited. Now D is the top of the stack. So D with the adjacency elements A and F. It has no nodes unvisited. So now D is popped from the stack. Now F. Now F is on the top of the stack. So all adjacent nodes of F is visited. So F is popped from the stack. Next, top element is D. So all adjacent nodes are visited. A, E, F. So B is popped from the stack. So next A is on the top of the stack. A is the node which has all adjacent nodes are visited. So the algorithm terminates as all nodes are visited in order. So finally, this is the list visited: A, B, E, G, F, C, H, D. First you want to write nodes with adjacency node, then the stack representation and the list visited.